Okay, I think the time has arrived. Welcome to Introduction to Programming with Python. My name is John Ostlund, and I am not going to anticipate anyone will be able to pronounce my last name, so don't worry about that. I had intended to just dive right into Python, but then I remembered this is a class and people probably care about grades and stuff like that. So let me just briefly describe the work that I'll expect you to do and the way that you'll be evaluated for the course. There will be a homework assignment each week, and what I like to do is to split people up into pairs to work on the homework. And so of the two of you or possibly three of you that are in a given pair or group, the idea is that what you should do is to work independently to try to complete as much of the homework as you can, and then compare what you've done with what your partner or partners have done, and then agree on what you want to submit as your final result. It's a very good thing in programming to struggle and work on things yourself, and it's also a very good thing in programming to compare what you've done with what other people have done so that you can get ideas about different approaches that you might take. Okay, so there will be 6 homeworks altogether, and combined those will be worth 20% of your course grade. I expect, frankly, that you'll have to be exceptionally lazy and have an exceptionally lazy partner to not do pretty well on the homework. So take it really seriously and do well. We'll also have 3 quizzes in weeks 2, 4, and 6. The scores on the quizzes, your grades on the quizzes, will count for a total of 35% of your course grade. Each of the quizzes will be half an hour long and will cover the material from the previous week or the previous 2 weeks. Now, next week is week 2, and we will only have 1 week worth of stuff that I can ask you questions about. And then in week 4, I'll be able to ask you about weeks 2 and 3, and in week 6 I'll be able to ask you about weeks 4 and 5. So far so good. And then we'll have a final exam during the last lecture session at the end of the mini. So the final exam will be a 1.5 hour exam, and that'll be 45% of your grade. The final exam will be very much similar to the quizzes. It'll just be 3 times as long. Okay? Any questions about anything? Okay, well, yes?
Quizzes, the way you described it, they will not be cumulative from the beginning to the end, but the final exam will be?
Correct. The quizzes will cover recent material, but the final exam will cover the entire course, including the stuff that we talk about in week 6, which won't be covered on any quiz. Okay? All right, well, yes?
Do you have a preference if we use a PC or a Mac? Is there a difference?
The only difference between using a PC versus using a Mac is that I have a shot at answering your questions about a PC and much less of a shot at answering your questions about a Mac. But you're welcome to use either of those machines for homework. And you probably won't have any problem whichever machine that you're using. Anything else? Okay, well, I would like to just get into Python then. And if you do have any other questions about anything to do with grading, homework, quizzes, the exam, anything about Python, etc., I'm available more or less constantly. I typically start looking at my email around 9 o'clock in the morning, sometimes earlier, unfortunately. And typically we'll look at my email even late into the evening, 7 days a week. My wife had knee surgery in July, so I can't leave the house anyway, so so I might as well do something productive. So please feel free to go ahead and shoot me an email message about anything at any time, and usually I respond very quickly. I will also have physical office hours every Sunday in my office up on the 3rd floor from 11 a.m. to 3:30 p.m. if you have questions about the homework or about anything with Python, etc. All right, off we go. So we're going to start looking at very basic Python stuff. One of our assumptions about the people in this class is that you've had quite limited, if any, programming background. You know, you may be familiar with Excel, you may be familiar with the R statistical language a bit. You may have done some programming, but we're not expecting that you've written lots of programs in lots of different languages, and so we're going to keep things very simple and take things step by step. We will if my laptop wakes up. Hello. There we go. Okay, so what about Python? Well, Python, just within the last 3 years or so, has really sort of exploded into the business world as an extremely important language used by almost everyone for almost everything. It's an easy language to learn. It has a lot of powerful facilities built in. It's not necessarily a particularly safe language. You can shoot yourself in the foot fairly easily with Python. It's also not a very fast language in terms of execution speed. But in the arena of time trade-offs, you know, when people are concerned about efficiency in programming, it's often the efficiency of the programming process that's more important than the efficiency of the program that you produce when you're all done. My law of efficiency is, if it's fast enough, it's fast enough. If it's too slow, it's too slow. Okay, and there are, you know, all kinds of theoretical discussions of order n and order n squared and order n log n kind of efficiencies, and those matter very much when you're dealing with mountains of data in applications that you have to run on a, you know, daily or hourly kind of basis. But most of the time what people use Python for is to do sort of data analysis kinds of work that R might be appropriate for also, or more sort of fancied up kind of spreadsheet work like you might use Excel for. Very often people write Python programs to solve one problem one time, and the goal is to get the program written and working quickly rather than be concerned too much about, you know, is it running in a half a second or is it running in a tenth of a second, you know. Okay, it's a multi-paradigm language. It supports both old-fashioned so-called top-down procedural decomposition, which I will describe as we go. And it also supports object-oriented programming, where you have these chunks of data called objects that have certain interfaces that you can talk to get various responses. That also I'll talk about more. Okay, so Python is easy to write. It is a scripting language, and hence is slower inherently than compiled programming languages like C or C++ or Java. Now, despite that the documentation has a cute little symmetrical icon of a couple of snakes, Python was actually named for the Monty Python British comedy troupe, which is so old that I was a big fan of it when I was young, and maybe you've heard of it or maybe not. If you look through the Python documentation, you'll discover a whole lot of sort of inside joke references to various Monty Python skits. It is an open source project. It was originated by a fellow named Guido van Rossum, who is still actively involved. He has been appointed the benevolent dictator for life of the Python project. There are subparts of Python, like the NumPy n-dimensional array package, or the pandas spreadsheet and time series packages. These also have their designated benevolent dictators for life as well. And there is an open source group called the Python Software Foundation that, in some sense, controls what Python officially is. There are two different Python versions out in the world. There's the 2.x version, and what I hope is obviously to you the more recent 3.x version. 2 or 3 years ago, it was kind of a coin flip as to which one of these you would want to learn, but Python 3.x definitely overtook Python 2.x about 2 years ago, and in fact, it's been announced that Python 2.x is going to be retired. So we're going to be working with Python 3.7, which is the latest and greatest version of Python. You might encounter, if you have to work with older code, you might encounter this other older version of Python. All right, I'm going to presume that either you already have or you soon will download and install the Anaconda package from July of 2019. That will make sure that everybody has the same stuff and that all your stuff is up to date. There are certain things missing from Anaconda. For example, there's an integrated development environment that a lot of people like called PyCharm. And PyCharm is not part of what you get when you download Anaconda. But mostly what you get is all of the basic low-level Python stuff plus NumPy, Pandas, Matplotlib, and a whole bunch of random names of important packages that at this point probably don't mean anything to you. But if you download Anaconda, you will then not have to go out and download individual other packages all that much. So far, so good? All right. All right, so we're going to launch Anaconda. Now, I kind of messed up my left ankle, so you'll forgive me if I crouch down here and hide behind my laptop a little bit. When you start the Anaconda prompt, you get what looks like a command.com window if you're using Windows, or you get a shell interface if you're using a Mac or Linux for that matter. And from that window, you can then execute some integrated development environment of your choice to allow you to interact with Python. The very simplest of these integrated development environments is the one that's built into Python. It's called idle. And if you start idle, you will get a Python shell window appearing on your screen. I can see that, yes, indeed, I do have the most recent, very close to most recent version of Python installed. You may end up with Python 3.7.4, I'm not sure. Anyway, and this triple greater than symbol here is the shell's prompt. At that prompt, I can type Python code, and the shell will interpret that code. If the code produces a result, the shell will automatically display that result to me on my screen. So if I say something like 4 times 17, yay, I get 68. I eventually get 68. My laptop seems to be gruesomely slow this morning, or this afternoon, whichever. Okay, so there we have our shell window. The triple greater than sign, as I said, is the prompt, and you can just use Python as a sort of overly complicated calculator if you want to, and just type mathematical expressions to the prompt, and it will compute them and display values. If you do want to get out of idle, the idle shell, you can use quit. I'm pretty sure. All right, quit. All right. Now, I don't know to what extent you consider yourself, being a programmer or being a data analyst or being a business analyst or what have you. But this is a nice example of something that drives non-computer people completely bananas about programs in general. I've typed quit here, and if I say enter, it doesn't work. It knows what I'm trying to do. It knows I'm trying to quit, but it says, no, you have to type quit with parentheses if you want to quit. And so if I do that, yes, it will actually let me out. I get asked to confirm whether I want to exit, and I'm going to cancel this to remain in my shell. Okay. You can put comments in your Python code. In fact, any text that you type from a pound sign or sharp sign to the end of the current line will simply be ignored by the shell or by the interpreter. So if I say A gets 123, the single equal sign does what's called an assignment operation. The thing on the left has to be a valid name for some variable that I want to create. And the thing on the right has to be some value, some appropriate value that I want that variable that I'm creating to refer to. And then from a sharp sign or pound sign to the end of the line, that's just ignored. All right, so what I've done here is I've created a variable named A, referring to this integer value 123. And I can see what value A is currently referring to by just typing its name. All right? Here's another example where I'm creating a variable x, and that is referring to what's called a floating point number. That is, it's a number that has a fraction part as opposed to an integer, which does not. Oh, I should have a comment in here just for gags. I don't know if it matters if I spell comment correctly in a comment or not. All right, so I've now created x referring to 2.7. And Python will just remember these variables until I either restart the shell, which I can do, or exit from the shell and start a new session. Okay, so to keep track of values as your program is running, you're definitely going to need several variables probably. And so you need to know what the rules are as far as what you can name your variables. It turns out that the very first character in a legal variable name has to be either a letter or an underscore character. Letter means either uppercase or lowercase. And in Python, the two different letter cases are distinct. So little a and capital A are both valid, but they are not the same. Okay? Here I'm saying A gets 3, and I still have lowercase a sitting around referring to 123. And now I have this additional variable, capital A, referring to 3. Following that initial character, you can have 0 or more additional characters that are either letters or decimal digits, that is base 10 digits between 0 and 9, or underscores. So you can have any mixture of those things following the first character. The first character has to be a letter or an underscore. All right, so it's not legal for me to say 3 gets A, because 3 is not a letter. And actually, I mean, conceptually, I hope it strikes you as a good thing that I can't say 3 gets A. I can say underscore 3 gets some value, because underscore is valid as the first character in a variable name. This is probably going to be confusing to somebody reading your code, but underscore 3 is a perfectly valid variable name. One of the advantages of being able to use underscores in variable names is that you can use underscores to split up multiple words to provide very meaningful variable names. So I can say has n. Okay, well, I got a bizarre copy and paste there. Try that again. Hey, come here. Okay, has n apples equals 12. Okay, so has n apples with the underscores is going to be a lot more clear to somebody looking at this than has apples. You know, if I left the underscores out. And so I'll use this as motivation to say, when you are writing programs, do try to use meaningful variable names that explain what the variables are for. If you write programs where all of your variable names are IJK, MNO, XYZ, then even you yourself next week are not going to remember what the heck those variables are supposed to contain. Comments are a good idea, but having self-explaining variable names is the best of all. All right. Here I'm creating 4 more variables with variations of a's. Little a, little a, little a, big A, little a, big A, big A. These are 4 completely independent variable names. Be careful not to use symbols in variable names. Some languages allow this. In fact, some languages require this, but Python does not allow this. So in Perl, how many of you have ever done anything with Perl? See, 10 years ago, I would have been teaching you Perl and telling you that you had a career forever using Perl. Now nobody uses Perl. Actually, I wouldn't have done that to you. I didn't like Perl. I never used Perl. Python is, I believe, going to have an enormously more staying power than Perl has turned out to have. Anyway, so you can't use symbols like $signs. Be careful not to use hyphens in variable names, because the hyphen is actually the minus symbol. And so if I say cm dash per dash foot, Python thinks I'm accessing the variable cm and I'm subtracting the value of per, and then I'm subtracting the value of ft. So that's not gonna work. Okay. Any questions about anything so far? Yes.
I just wondering, why are we using the shell and not the other programs that are in the Anaconda?
Oh, good question. There is a distinction between the language and the tool that you use to develop code in the language. And I want to keep that distinction very clear. A lot of people, for example, my other biggest hat is writing C++ code. A lot of people think that Microsoft Visual Studio is C++, but it's not. You can use it to develop C++, but it's only one environment in which you can develop C++. There's also, the GNU C++ compiler and Eclipse and a whole ton of other C++ compilers. So I'm trying to maintain this distinction between the language versus the environment that you're using to develop the language. Now, I will shortly start using an editor that IDLE provides, in which I can type Python code. So I can say things like A gets 13 and print A. And this enables me to develop stored programs in Python. The idle editor is, as you can see, mindlessly simple. I like to use it because it doesn't have any screen clutter. I mean, it is just a box that you type text into. But if you're writing bigger programs and you want a nicer environment, or you want better feedback and better support, other integrated development environments like Spider or PyCharm or Jupyter and so on, you'll probably prefer those. But I don't want to impose one of those on you, and I don't want to have to explain all the stuff on the screen that's not Python. Okay? Anything else? Okay. Let me save this with a name just to show what is up. All right, so I'm going to get into my... Actually, I probably didn't even create a directory for this yet. So let me create a folder called Introduction to Programming with Python A1 2019. And I'm going to just call this thing example 1. Okay, so now I've created a stored program that has two statements in it. The first is an assignment, and the second is a print function call. And when I run this guy by pressing F5, yay! It restarts my shell and runs the program, and I get 13 printed on my screen. Okay, so after today, we're going to be doing increasingly amounts of this stuff, where we'll have stored programs and files that are multiple statements long. But right now, I'm just introducing basic tools. Now, I just remembered something exciting, which is that when I run a stored program, it restarts my interpreter, which means that all of the variables that I created previously have been thrown away. So I no longer have little a. I no longer have. Oh, wait a minute! I do have little a. But it's this one. It's this little a. It's not the little a that I assigned 123 to. So let me recreate a to refer to 123. X is gone. Capital A is gone. What was X? Oh, who cares? 2.7. I don't remember what it was. And I'm sorry?
X was 2.7.
You see how imaginative I am, that I always come up with the same random examples. And A gets 3 or whatever. Okay. Okay, so now that we know how to create variables and we know how to store values into variables and how to see what a variable contains, pretty much the next thing anybody needs to know how to do in any programming language is how to do arithmetic, so you can perform computations. And Python has the usual suspects of arithmetic operators. We've got addition and subtraction, and we've got multiplication and division. It turns out that multiplication and division have a higher level of precedence than addition and subtraction, and this is what you would expect from what you learned in elementary school. So if I say 3 plus 7 times 2, well, we know here that the multiplication is going to be performed first in preference to the addition. So I'm going to compute 14, and then plus 3 is going to give me 17 as my result. I can use parentheses if I wish to override the precedence or change the precedence. There are also so-called associativity rules, which again are what you're already probably familiar with. All of these basic arithmetic operators associate from left to right. So in other words, if I say 8 minus 4 plus 3, that's not interpreted as 8 minus 7. It's interpreted as 8 minus 4, which is 4, plus 3, which gives me a 7. If I wanted to get 8 minus 7, I could say 8 minus and then use parentheses. Wow! Any questions? Yes?
Do spaces matter?
Ah, excellent question. Do spaces matter? No, not at all. When you are writing code as part of a team, style matters. The style of your code matters, and you want to adopt the style of coding that your team members have. Sometimes the company will dictate what this is supposed to be, and sometimes the team itself just has, its own sort of formal or informal style. And I have the spaces in here just because that's my style. But if I said, 8 minus 3 plus 4 with no spaces at all, or if I said 8, tab, whoop, oh, whoop. Okay, so the tab, I had forgotten. The tab is special to the shell, so I can't actually use the tab. But if I say 8, and just hold down the space bar, how much space you have or how little space you have just doesn't make any difference between values and operators. Now, obviously, A is a variable, capital A is a variable, A capital A is a different variable. So in that case, if you're separating so-called identifiers from each other, you would need to have a space in between. Actually, if I do this, I'm just going to get an error anyway, because Python doesn't understand what one variable name followed by another variable name is. I could say A plus A, and that will work fine. Okay? Okay. Now, division always produces what's called a floating point result, even if the fraction part is 0. So if I say 5 over 9, I get 0.55555, roughly 15 digits of precision. And Python insists on showing me even the last digit, which is typically incorrect. So we know that 5/9 is actually a repeating fraction. It's 0.5555 forever. And so you might look at this and think to yourself, oh, okay, well, fine, Python is just rounding here. That's cool. Actually, no, that's not what's happening. Well, we don't know anything about sevens. I'm sorry?
1 by 3.
1 over 3. Okay, that again looks like rounding. I'm trying to come up with an example that the last digit is just completely wrong. And I should have memorized that before I showed up, and I forgot. But you'll discover when you do divisions that that last digit that you get in the output by default is really just garbage. And it may appear to be garbage that's close to right, or it may be garbage that's obviously garbage. Okay, you just can't trust that last digit that's displayed. Oh, duh. Here on slide 12, I have an example. So what I'm doing here on slide 12 is a Fahrenheit to Celsius temperature conversion. So to convert a Fahrenheit temperature to Celsius, I would say 5/9 times, and then the Fahrenheit temperature, here we're using 80, minus 32. Okay, so 80 is my Fahrenheit temperature, And if I want to convert that into a Celsius temperature, I subtract 32 and then multiply by 5/9, and I get, come here, and I get 26.66666, and this is a repeating fraction. Oh, look at here. 8 is clearly wrong. If it were really rounding, I would have a 7 there rather than an 8. All right, so that last digit is just bogus. This example that I've just shown here, 5/9 times the quantity 80 minus 32, that's basically only meaningful at the moment that you type it. If you type that on your screen and go buy a sandwich and come back and look at your screen again, you're probably not going to remember what the heck you did that for. So here's another case where using variables is a really good idea, because variables will help you remember why it is that you did this thing in the first place. So instead of typing in these so-called magic numbers, let me instead create a variable, var, containing 80, and then compute that Celsius is 5/9 times the Fahrenheit temperature minus 32. And now I have a much more meaningful thing on my screen that sort of self-documents what I'm trying to do. Make sense? All right. Python, unlike a lot of other languages, has a built-in exponentiation operator. So if I say 2 * 3, that computes 2 cubed. So in other words, I should get an 8 from that. It turns out that that has the highest precedence of all of the arithmetic operators. So it has a higher precedence than the star and the slash that we use for multiplication and division. Also, another thing that's a little bit peculiar about exponentiation is that it associates from right to left rather than from left to right. Did I do that right? From right to left, yes. So if I say 2 * 3 * 2, well, if you're expecting things to associate from left to right, you might say to yourself, all right, well, 2 cubed is 8, 8 squared is 64. But that's not the order that things are done in. Instead, the rightmost one is done first, so I get 3 squared is 9, and then 2 to the 9th power is 512. It is. 2 to the 10th power, just here's a computer sciencey thing to know. 2 to the 10th power is where we get our idea of 1K from, which is 1024, and 2 to the 20th power is 1 meg, and 2 to the 30th power is 1 gig. So so I know that 2 to the 9th is just half of 2 to the 10th, 512. You don't care. All right. Now, Python integers are arbitrary precision integers, and you can ask for truly giant values. So 2 to the 100th power is no problem. There we are. In fact, 2 to the 500th power is no problem. 2 to the 5,000th power is no problem. Now, I may have to wait for a moment, and then the number is going to go off the top of my screen. Oh, wow, that was fast. Okay. So this is one of the things that's cool about Python, is that you can do calculations involving arbitrarily large integer values. Okay, the examples shown here are things that I've already done, 512 versus 64. Here's one that might trip you up. if you say 3 times 2 to the power of 4 minus 2, this is a good example of why spaces just don't matter. Because you look at this the way it's spaced out and you think, okay, what we're trying to do here is to compute 6 to the power of 2. But Python doesn't care about spaces. It only cares about precedence rules and associativity rules. And so what Python is going to do is compute 2 to the 4th power and then multiply that by 3 and then subtract 2. Okay, so that's the actual result that I'm going to get when I say 3 times 2 space star star space 4 minus 2. It's not going to be anything like 36. 6 squared would be 36, but I don't get that. So what does this mean? Well, it means, unfortunately, that you do have to know the precedence rules. You do have to know the associativity rules. You should use style as far as spaces between things, but you need to understand that spaces don't control what the interpreter does. Okay? Okay. So we know what subtraction is about. If I say 10 minus 5, this minus symbol here is a subtraction operator, and I get 5 as a result. This is what's called the binary minus symbol. It turns out that there's also a unary minus symbol that just takes one operand on its right side. And this is how you create negative numbers. The minus is not merely being used here to create a negative number. The minus is actually an active operator that's giving you the negative of whatever it's applied to. All right, so if I say 10 minus 5, well, this is going to be 10 plus 5, and so I get 15 here. If I say 10 minus 4 times 3, notice here that this unary minus sign is being applied as an operator to the result of that multiplication. That's fine. So I'm going to compute 12, then I'm going to get the negative of 12, and I'm going to say 10 minus 12, so that'll give me a 22. It turns out that the unary minus sign has higher precedence than multiplication and division. But it does have lower precedence than the exponentiation. So let me jump ahead here. Oh, I wanted to show you one more kind of little warning here. One implication is if you say minus 5 squared, once again, you have to know that the star star has a higher precedence than the minus. So this is going to end up computing the negative of 5 squared, not the negative of 5 squared. All right, if I want the negative of 5 squared, I am, because of the precedence rule, is going to have to put parentheses around the minus 5. There is also, just so you know, there's a unary plus that gives you back the same value that you applied it to. So in real life, nobody ever uses a unary plus because it doesn't do anything useful. but it's there just to pal around with the unary minus. And the complete set of I jumped a couple, I'll come back to them. The complete set of operators with their precedence and associativity is shown here on slide 20. So exponentiation has the highest precedence of all. Then the unary plus and minus have the next highest precedence. multiplication and division follow the unary plus and minus, and then just plain binary addition and subtraction have the lowest precedence. This is mostly what you would kind of expect from how you were taught arithmetic anyway. The only one that's a little surprising here is the star. Okay. Well, let me take a look at the two that I skipped over. One that I skipped over, which has the same precedence level as multiplication and division, is something called modulus, the percent sign. And what the modulus gives you is the integer remainder after division of one integer by another. So if I ask for 14 mod 5, all right, well, 14, if I divide 14 by 5, I have I have 10, right? The quotient, yes, thank you. Okay, so I've got a quotient of 10, and the remainder here is going to be 4, and so that's what the mod gives you, is the remainder. One trivial but common thing that people use modulus for is to detect whether some variable is an even or an odd number. So if I say a mod 2, well, a must be an odd number. And in fact it is. And a mod 2, oh, it's also an odd number. Okay. So that's a trivial thing that people often use mod for, is to tell the difference between even and odd numbers. And another very important arithmetic operator is something called floor division. Now, when you say 17 over 3, plain division always gives you a floating point result, which means that you do have a fraction part. And in fact, that's going to be true even if the fraction part is 0. So if I say 3 divided by 1, well, we know that 3 divided by 1 is 3, but actually it's represented as 3.0. So it's stored as a floating point number in the machine. Now, if I only want the integer part of the division, I can use the double slash. So if I say 17 floor divide 3, 17 double slash 3, I'll get the division, and I'm only left with the whole part, with the quotient part of that division. And the fraction part is thrown away. So, and notice that the result is an integer, not a floating point number. Okay, so it's going to be the case that 17 floor divided by 3 times 17 plus 17 mod 3. In other words, floor dividing gives you the quotient part, modulus gives you the remainder part, and if you add those things back together, you should... See, I can't do arithmetic in front of people. You see what I did wrong? This should be a 3. Oh, well. I did remarkably well. Yeah, I made it almost 50 minutes without doing something silly. All right, so I meant 17 floor divided by 3 times 3, and then plus 17 mod 3. Okay, so between the floor division and the modulus operator, you can break integers down into subcomponents, if you will. And that's it. So now you know everything there is to know about arithmetic. Yay! Any questions? Okay. So I've been talking about integers and floating point numbers. Int and float are actually what are called data type names in the Python language. And every arithmetic expression that you have in a Python program has both a value and a data type associated with it. So 3 not only has the value 3, but it is also an integer, an int, and I can in fact ask for, I'm jumping ahead a little bit, but I can ask for the type of 3, and I'll be told that it's an int. 3.0, on the other hand, is a floating point number, specifically a float. And internally in the system, these are stored differently. The int is stored in an arbitrary precision integer format. The float is stored in what's called a 64-bit floating point representation. Okay. So, even though the values match, how these things are stored in memory is different. And also, the range of possible values that you can have is therefore also going to be different. Let me show you what I mean. I said that integers are arbitrary precision. If I compute 2 to the 10,000th power, that's going to be fine. And, you know, it goes sailing off the top of my screen, but that is an accurate representation of 2 to the 10,000th power. On the other hand, if I ask for 2.0 to the 10,000th power, well, 2.0 is a float, and it turns out that because of the 64-bit pattern of bits that's used to represent floats, I can't store a number that's that huge in a float. So I'm going to get yelled at here instead of getting a result. I get told result is too large. So 2.0 to the 10,000th power can't be computed. All right, so this is annoying. It means that you can't just do, well, I don't know. I mean, you're already used to this idea from spreadsheets and ordinary calculators and so on. You can't do arbitrary precision floating point arithmetic in Python, just as you can't do arbitrary precision floating point in just about any any kind of language without without some kind of add-on software that tends to take forever to run. And even then, of course, you can't represent transcendental numbers. You can't represent pi because it doesn't end. Okay. Okay. So, the reason that Python stores floats in this 64-bit format is because that is the format that most computer processors are efficiently able to process directly. Right? Your Intel chip or your AMD chip on your Windows box or your Mac has built in the ability to very fast manipulations of floating point values in the 64-bit representation. Increasingly, there are machines that handle 128-bit representations very fast as well. That sounds great, twice as much, but actually twice as much as a restricted range is still a restricted range. Right? Okay, so in fact, it turns out that for a float data type, you're going to be able to store values between 10 to the minus 308th power and 10 to the plus 308th power, but if you try to get magnitudes that are outside of that range, you're going to get yelled at. Also, a float is only able to keep track of about 15 decimal places of precision. Beyond that, whatever you get is just garbage. Let me show you sort of jump ahead a minute here. If I compute 2/7, by default I get, is that 15 or 16? 5, 10, 15. Okay, so the first 15 digits are accurate. Then any after that are just some kind of garbage. I can demand, using something called formatted output, I can demand to see 25 places of precision for my floating point number. And what I have is even more garbage. Okay? So what I have here is accurate out to the 15 digits. And then here I have garbage, 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 garbage. But you might mistakenly think, if you saw this on a computer printout, that, oh, that's a very precise calculation. No. It's just garbage, 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 garbage. All right? All right, I already illustrated the type function. You can use the type function to find out what the data type is of any arbitrary expression, such as a constant. So how do you know, when you do arithmetic, what kind of result you're going to get? Well, there's actually some rules here that are pretty straightforward. If you do any kind of arithmetic involving integers, positive integers, the result that you're going to get is going to be an integer, except for division. When you do division, you always get a float, period, end of story. Okay, so division always gives you a float. Otherwise, if one value or the other is a float, then the result, then the result is going to be a float. So here, 2 point to the 4th power is the same value, but not the same representation as the integer 2 to the 4th power. So that's 16.0 rather than 16. The other situation where you can have 2 integers involved and still get a floating point result is a negative exponent. All right, so 2 to the minus 4th power is really the same thing as 1/2 to the 4th power, and so you're implicitly doing a division there, which is going to end up giving you a floating point result. But otherwise, 123 minus 4 is an int. 123 floor division by 4 is going to be an int. Some number mod, some other integer is going to be an int. But if any one of these or both of them is a float, then the result is going to be a float. So 123 floor, this is going to look bizarre, but if I say 123.0 floor divide 4, floor divide does not mean to give you an int. Floor divide means to give you an integer value at the floor of the division, but in this case the result will be an integer value in a float. So I have 30.0 as my result here, as opposed to the 30 that I had up above. All right, we went quicker than I anticipated. Is anyone deeply offended if we go ahead and just call it a day here? Okay, so if you do have any questions, as I said, shoot me an email. Now, I'm going to confess something here. I'm teaching 3 different Python courses at 3 different levels to 3 different groups. And so I will routinely forget what I have said to you versus what I have said to other people. Did I tell you about my office hours and things like that? Oh, I'm so glad. All right. Okay, so we will pick up where we left off here on Thursday, and I will see you then.